This is a real quick lesson on Newton's law of cooling. Newton's law of cooling is really a special case of separation of variables and growth and decay, sorry. Okay, what the Newton's law of cooling states is that the rate of change of temperature of an object is proportional to the difference between the object's temperature and the temperature of the surrounding medium. Okay, so basically if you take turkey out of the oven, set it in the kitchen, there's a law of how long it's going to take for it to cool, and it's proportional. So here's my example. Y represents the temperature of an object in a room whose temperature is kept at a constant 60 degrees. The object cools from 100 degrees to 90 degrees in 10 minutes. How much longer will it take for the temperature of the object to reach 80 degrees? Well, from Newton's law of cooling, we know that the rate of change in Y is proportional to the difference between Y and 60. So you start out by writing your differential equation. So dy dt is equal to a constant times the temperature and the temperature of the room, which is 60 degrees. All right? And then you separate your variables. 1 over y minus 60 equals k dt. You know that's the natural log, so you have the natural log of y minus 60. This is kt plus c. When you take the e to the power, you end up with y minus 60 equals c e to the kt. We've done that many times. All right? So now y is equal to 60 plus c e to the kt. And we have to solve for c. Well, we know that at t equals 0, y is equal to 100. Okay, so we know that. That was a given. So we're going to plug that in to find k. So you put in 100 equals 60 plus c e to the 0. So c is equal to 100 minus 60, which is 40. So now my equation is y equals 60 plus 40 e to the kt. And now I'm going to use this information to find k. So you end up with 90 equals 60 plus 40 e to the k times 10. You subtract 60 and you get 30. Divide by 40. Take the natural log of both sides. 3 over 4 equals 10k. So k is equal to 1/10 the natural log of 3 over 4. And if you put that in your calculator, you get negative 0.02877, which makes sense because the temperature is decreasing, so it should be negative. And then it says, how much longer will it take for the temperature of the object to reach 80? So you put 80 in here, 60 plus 40 e to the negative 0.02877 times t, and you do the math. 80 minus 60 is 20, and you divide by 40. Takes the natural log. So the natural log of 1/2 equals negative 0.02877t. You do the math, and I got t is equal to 24.09 total minutes. But they asked and said how much longer, so you have to subtract the original 10. So the true answer is 14 minutes longer. Okay, so make sure you answer the question. All right, down here at the bottom, this is the standard formula. Some people like to memorize it. I don't, okay? Test day rolls around and you panic and you get test day anxiety and you forget. You can always do this. It's the difference between the Y value and the temperature in the room. But here, your final temperature, the room temperature, the original minus the room, And you can memorize that if you want. It's up to you. That's all there is to this lesson.